So a forest ranger, forest ranger. So what is a forest ranger? They are basically it's a profession or a job where people, if you go to parks, not parks like Fanshawe Park, sorry, not parks like Victoria Park, I mean, an actual park, okay, a park with trails and a park with woods and so on, and they basically what they patrol the park. They're like police officers, but for parks. They're called forest ranger. Okay, parks officer is at the top of a watchtower. What's a watchtower? Just a tower, not super high, maybe like I don't know, 20 meters high, where they sit and they basically watch the park. So that has a height of how much? How much? 120 meters. That's a very high watchtower. Whether that is realistic or not, who cares? We just care about the math. There's a fire at some distance from her. Okay, she needs to look down. Look down. Why? Because she's standing way what? She's standing way too high. Okay, so is that an angle of elevation or an angle of depression? There you go. When you look up, it's an angle of elevation, like the tower. When you look down, it's an angle of depression. You look down. She needs to look down at an angle of depression of 4.5 degrees to see the fire. So basically, everyone, this is what. So I'm just gonna use this. So she is standing up and she's looking straight. Everyone, she just needs to look how many degrees only down? No, not 45. 4.5. So 4.5 is a small angle. So all she has to do is this. That's it. Just a very small tilt of the head. Okay? All right. I'll clean this after. All right. So the question is, if she is 120 meters high and she only needs to look this much, how far is the what? How far is the fire? Okay, round your answers to one decimal place. Okay. We always need to sketch a what? Diagram. Okay. So what do we need to sketch first on the diagram? Come on. What was the first thing we sketched every time yesterday? The ground. Thank you. There's always a ground. So go ahead, everyone, and let's sketch a ground. So here's the ground. Okay. How do you sketch a watchtower? You just sketch like a building with like a little box on it that she stands on. So everyone, here's the watchtower. Sorry, watchtower like this. Maybe made of wood. Who cares? Okay, and she is right here. Okay. Do you think that the fire is close or far away? Everyone, if I look down like this, where's the fire? Yeah, like right beneath me. But if I just look like that, where's the fire? Very far. So that's why we're gonna put the fire somewhere in here. How do you sketch a fire? Well, I'm gonna use red, and I'm just gonna sketch something like that. That's a fire. Okay. So she needs to look for everyone. She needs to look this way. Look. So I'm gonna sketch this. Now, can someone tell me where is the 4.5 degrees? Is it here or is it here? On the hype. See, both of them are around the hype, but I'm asking, is it below the hype or above the hype? I'll give you a hint. Look at me, everyone. She was looking like this, and then she looked this way. Exactly. So is it, think about this way. There's a line like this, and there's a line like this. Where's the angle 4.5? Here or here? Again. So which one is it? Is it this or that? Yes, everyone. Angle of depression is always the one right below your what? Your original eye line. Your eye line is here. When you look up, it's this much. When you look down, it's this much. Okay? So I want you to put 4.5 degrees here. Actually, okay, hold on. Let me change this a little bit. You're fine. You're fine. You don't have to change your diagram. But instead of the hypotenuse going to the top of the fire, let's go to the bottom of the fire. My bad. You'll see why. You'll see why right now. Let me just insert a line. It's gonna be easier for me. Yep. From here to here. Can anyone just guess why I change it like that? Sorry, so I can see the what? Okay, but what English letter do I? Yeah, Killen. Sorry, say again. Okay, I guess this is the base of the fire. But everyone. There's a listen up. There's a geometric reason I did it this way. Come on. What am I sketching with my hand? Z. There you go. How many people see the Z? So this angle is also where? What does the Z tell you? If there's a Z and this angle is here, where is it here? Is it this one or this one? Exactly. Oops, it's the same. It's the same corner. It's the same corner. Perfect. So, everyone, that's why. Put the Z also, sorry, I mean put the 4.5 also here. Nice. Do you see the right triangle? How many people see the right triangle that we're going to use right now? Yes, where is it? It's this line, and obviously this line. Where's the angle 90 degrees? Right here. Yep. So go ahead and put 90 degrees. Okay, let me just change this real quick. There we go. Nice. Okay. So which angle are we going to use? Are we going to use the one outside of the triangle or the one inside? Yeah, that's why I did the Z. Okay, so since we're going to use this angle, what do we do with it? We what? We put a circle on it. So I'm going to put a circle on it like this. Okay, let's label. Where is my hypotenuse? The what? The longest one, the dashed line. This one. Okay, where is my opposite to this angle? To this angle. Is it the ground or the tower? The tower. So, oh, how high is the tower? 120. So everyone, we can put 120 here. Sorry, I forgot. 120 here. 120 meters. 120 meters. And then put what on it? Opposite, as you said. That leaves this guy to be what? Adjacent. Perfect. So now, which side of those three do we know? Which side of those three do we know? Do we have a value for right next to it? Do we know the height? Do we know the edge? Or do we know the opposite? We know the opposite. Okay, which one of the other two are we trying to find? Are we trying to find the hypotenuse or the adjacent? I'll give you a hint. We're trying to find how far the fire is from the tower, not from the person. Actually, if you find the hypotenuse, Sadia, if you find the hypotenuse, you're finding how far the fire is from the person. We want how far the fire is from the what? The tower. Which distance is that exactly? It's the what? It's the ground. So we need to find the what? The adjacent. So what do we need to relate? What side and what side? Or which side do we not need? The hypotenuse. So which two are we trying to relate? You got it. So go ahead. we relate. We relate opposite and adjacent. What do you use? Thank you. Okay, once you know what to use, how did we start every problem yesterday? What did we first write? Once you knew what to use. Every time we wrote this statement, what did we write after? You can flip the page. Tan. Okay, so tan of which angle? Whatever we circled, 4.5, 4.5 degrees. Thank you. Yep, keep going. Yeah. Opposite over adjacent. All right. How am I going to find tan of 4.5 degrees? What do I use? Machines, calculators, yes? So I'm going to open up my trusty calculator right here. And what do I do first? Do I press tan or do I enter the value? Mine accepts the number first or needs the number first. 4.5. Do I press this guy? Tell me why not. You're right, it's a no, but tell me why not. Why do I not need the second, Shadi? Guy, I'm not finding an angle, I'm using it, which means I already have it. So I'm just going to hit what, 10? Okay, how many decimals do we take? 4. Okay, so 0, 7, 8. Does that stay as 7? Of course, because after the 0, 0 does not do anything. So 0, 7, 8, 7. Okay, let me remember that. 0, 7, 8, 7 equals. How long is my opposite? Yep, 120. Now, what should I put here? Again, I could put A. Could I still keep writing ADJ? Could I put X? Could I put question marks? No, not a good look. No teacher will ever accept question marks in a what? In an equation. They accept them on what? On like this, on diagrams, but not on equation. So you know what? I like to call it ADJ. Please feel free to call it like Jaden said, A, small a though. Okay, what do I do? How do you always do anything like this? What do you do? No. Sorry, show the one, yes. And then what's the process? Crisscross, cross multiply. Okay, hold on. One question. Yesterday, every time we cross multiplied, flip the page, everyone. Every time we cross multiplied, the thing we were trying to find multiplied what number? Every time. Is it the same case this time? Sadly, no. Is the ADJ multiplying the 1? No, it's multiplying what? This guy. Okay. Is that still okay? Yes, 100%. Everyone, we are at this stage now. Look. We are at this stage. Look. 5 over 1 equals 7. Can someone tell me how to solve this one? Do we still crisscross? Yes. But what do you get? What's 7 times 1? 7. But what's x times 5 or 5 times x? 5x's. By the way, get used to this 5x and so on. We're going to use it a lot when we do quadratics. Okay? But that's not until the end of the course, so don't worry about it now. So 5x equals what? Equals 7. And once you get to that stage, how do you solve anything that looks like that? So what divides what? So this one stays the same. This one just goes where? At the bottom. Does it become negative though? Because someone says it became negative because it crossed the equal sign. No. Are we adding, subtracting, or dividing? Yes, when you divide, you never change the sign, even though it appears to have gone to the other side. So x is equal to what? X is equal to 7 over 5, and which is 1.2. Sorry, 1.4. No, 1.4. So here is the same thing, but we just have a decimal. So what do we have? 0.7787 ADJ equals what? 120 times 1, which is 120. And then ADJ, exactly, the 120 divides by 0.0787. That's going to be 1,500, I do remember from before. It is 120 divided by 0.0787. Ready? All right, yes. 1,524 dot, 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 dot. How many decimals are we rounding to? What does the question say? Come on. 1. So that means I'm going to start here. Sorry. I'm going to keep going, going, going. And I only cover this. It becomes, this one becomes what? Because this 7 is going to bump up this 7. Nice. So 1,524.7 meters. 1,524.7 meters. Is this a small distance or a far distance? Oh, sorry, 0.8. Okay. Sorry. My brain says something, my head does something else. They're not related. Is this a small distance or a far distance? Does that make sense? Did she have to look straight down or just a little bit? A little bit means what? It's very far away. If she looked straight down, it would be very close to the what? To where she is, or to the tower at least. Okay? Perfect. By the way, what's a good, again, everyone listen up. I'm not going to do that this unit. This is actually coming up in the next unit. What's a good scale when you have 1,524 meters? Is there another distance unit you can use? I mean, it's not too bad here, but what would it, what, yes, please. Kilometers, or we could also use what? Miles, but I'm going to do that when I teach you the unit conversion between miles and meters and kilometers. But you're absolutely right. Okay, and that's it. That's it for that problem. Yes, problem. Listen up. What? Oh, the comma is just what? The comma is just a way to what? Organize your numbers in groups of what? Of threes. So when do you use commas? Once you cross any number 1,000 or bigger, because 999, okay, 999, how many digits is that? 3 digits. But when you go 1,000 and beyond, how many digits do you have? 1,000. How many digits? 4. 1, 0, 0, 0. So then you can start what? Putting commas like this. Look, if you write a big number, you see what it does? It starts putting commas. Always you start from the right. So threes, 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 and that's it. You're done. It's just a good counting just to make sure that you have things grouped. So especially when you hop, it's easier to hop in threes than just one by one. Okay, that's all. All right, next one. Okay, this one. We have two people. Hey, we have a Hiba. Okay, Hiba and Matt are standing on opposite sides of a tree. Okay, the tree, you know for a fact, is how high or how tall? 9.3. So this distance from bottom to top is 9.3. Okay, Hiba is here. H is Hiba, M is Matt. Hiba needs to what? Look, of course, to see the top of the tree, and you're down, you have to look up. So she needs to look up at what degree? So where's the 47? Here or here? Always. Yes. Hey, remember, she's like this and then looks up. So where's the 47? Right here, right between the ground or her eye and where she looks. So everyone, let's put 47 degrees here. Go ahead. 47 degrees here. 47 degrees. Okay. To see the top of the tree. Matt on the other side needs to look up how much? 35. So where's his 35? His 35 is right here. Same location, just other side. By the way, question for you. The fact that she needs to look 47 and he needs to look up 35, does that mean they are at equal distance from the tree? No way. If they were, they would have to look up the what? The same amount of degrees. But one of them is further and one of them is closer. Always the closer one has to look higher. So that means the distance is smaller. Okay, the question is easy. How far are they apart? Not how far is each one from the tree, how far is the full distance from them? How many right triangles do you see here? One or two? And I kind of what divided the table to kind of lead you to the what to the answer. However, let's put some meaning to those symbols. M is who? Matt or Matt's location, so we can just say Matt. H is Hiba. T is top of tree or tree top. Tree top. B is tree. You can say bottom or base. I'm gonna say base. Perfect. Okay. Does it really matter which triangle you start with? Nope. They are identical in work, not identical in shape. In work, so that means what? Whatever you do for one, you have to do for the other. Just do me a favor and run a line through the tree to make sure that you see your triangle like this. Perfect. So it's a 90-degree here and a 90-degree here. Okay, we're ready. Let's okay. Hiba's triangle. Okay, everyone, let's sketch Hiba's triangle real quick here. Go ahead and just sketch a generic. Okay, that was a bad line. I need to stand here. Okay, let me erase this a little bit. Nice. Okay, what's this one? Capital H. What's this one? Capital T. What's this one? By the way, did we ever label heads or corners in trigonometry so far? In trig. Where did we always label heads or corners? In what? Similar triangles and Pythagorean theorem and that kind of stuff. Well, you know what? Didn't need to do that, but you know what? Let's just copy that part of the diagram. Where's the 90 degrees? Right, that's the base of the tree. Okay, which ones of those do we know? We know the distance from where to where? From the top of the tree to the base of the tree. So go ahead and put 9.3 here. 9.3. You don't have to put meters. We understand what it is. Okay, how much is my angle here? 47. Okay, let's label the sides. Hypotenuse always goes first. Where's my opposite? Is it the ground or the tree? 9.3, the tree itself. So OPP. Let me zoom in so you can see. There we go. Finally, ADJ. Okay, which one do we know? Which one are we trying to find? Yeah, we don't know. We don't need to know how far she is straight to the tree. We need to know how far she is from the base of the tree, so on the ground. Good. So we relate. Go ahead. We relate. We relate opposite and adjacent. Please go ahead. Oh, absolutely not. Absolutely not. These are my notes. This is me on paper. How much you choose to show me on your Google form quizzes and that stuff, you can just proceed with the math as much as you want. No problem. So use what? What is the only trig ratio that relates opposite and adjacent? Tangent, because it does not care about the hypotenuse. So use tan. Okay, so now we know how to start. Tan of 47 degrees equals up over edge. Okay, how much is tan of 47 degrees? I know one thing about it. It's more than 1. By the way, any angle bigger than 45 has a tangent of bigger than 1. Less than 45, it has a tangent less than 1. So 47. Which one? 10. Yep. Let's see how many we keep. Oh, my bad. Oh, sorry, I forgot. One more decimal digit. So does this 3 stay as 3? Nope, goes up to 4. So 1.0724. All right. 1.0724 equals. Opposite is known. It's 9.3. Adjacent is unknown. So I'm going to keep it as adjacent. What do? Show myself the 1. Remember, everyone, when you actually do cross multiplication in Google Forms, you cannot physically write fractions. What do you use? You use the what? Use the slash, okay? So you can they say slash 1 equals 9.3 slash ADJ, okay? Whenever you have any issues writing, write on paper and then call on me. I'll bring my laptop. I'll write it with you together. You just have to tell me what to write. Okay, what do? I crisscross. Crisscross. Again, is the ADJ going to multiply 1? Not in this case, but that's fine. We know how to handle it. 1.0724 ADJ equaling an easy 9.3, which means ADJ equals 9.3 divided by 1.0724. How much is that? I don't know. I know it's less than 9.3. I believe that's it. Okay. Can someone tell me what's the rounding situation? I forgot. What is it? One decimal. 8.6, but the 6 gets bumped up. Perfect. Thank you very much. 8.7. What unit? Meters. That's the distance. Okay, what do we do next? Do we repeat the exact same identical work for math triangle? Let's do that. By the way, can you tell me how math triangle slightly different is going to look compared to Heba? Is going to be bigger or lower? No. Sorry. What's his angle? So it's wider. Yes, thank you. So lower in height, but wider in base. Perfect. So go ahead and I'm going to sketch it right here, just like I did before. Here. Wide, like this. Yeah, that's decent enough. Come on, come on, come on. Yes. All right. So, 90 degrees. Everyone, solve and don't look at my solution. Try to do it on your own. Let's race each other, okay? Step by step. Look what you did here. Copy. You got it. Oh, I forgot to put my letters. This is the tree top. This is the base, but this is hiba. No, I mean Matt. Sorry. Um, not hype. Hype. Whatever. Hey, the coffee cup. Oh, we're good. Thank you so much. Thanks. Yep. ACJ and OPP, which is 9.3. Am I missing anything? No? All right. Do I still relate the same two? Yes, because the hypotenuse is still what? Irrelevant, unneeded, unnecessary. So we relate. All right. Tan, 35 degrees. I know this one is point something. 70020, so 7002. Oh, my bad. Up is the 9.3. Over, Jason, Chris, Ross. You see, identical work. You see how beautiful and easy math is when it makes sense? That's the whole idea. Everything is a story. How much did we get here? Anyone? How much did you get for the second? Haley? 15 points. Sorry. Does that make sense? Yes. He is what? He is closer or further? Because he is looking less. You look really far. If you look really high, that means you're like right under the tree. But if you look a little bit, that means you're far. So 13 point what? 3. And then what do? You pile up the whole thing. So 8.7 meters plus 13.3 meters is 8 and 13 is 21. 0.3 and 0.7 are point a whole one. So what's the answer? 20. Exactly. 22 is approximated to no decimals or one decimal. The way it looks like that. No decimal. But the question does say what? Show a decimal. If there's nothing, you slap a 0 next to it.